morning students, myself Dr. Bharti Patil, working as an assistant professor physics in Maharaja Jivajirao Shinde College, Trigonda, Ahmednagar. We have started our syllabus related to TYBSc solid state physics, and in that we have started our chapter number 4, that is magnetism. We have covered various points related to magnetic materials and their properties, and today we are going to solve few of the examples based on the magnetic properties of the materials, that is susceptibility and relative permeability. So let's start to solve our first example. Example is given as find the relative permeability of a ferromagnetic material if a field of strength 220 ampere per meter produces a magnetization 3300 ampere per meter in it. So, what is the example? In this example, we have to find out the relative permeability. In our theory lecture, we have used the notation. Suppose we want to find the relative permeability. Means we have to find out relative permeability. We have used the notation mu r, that is relative permeability. We have to find out what is the value of relative permeability. We know that relative permeability is the ratio of permeability of the material to the permeability of free space. So, it is a dimensionless quantity. Then, what are the given things of a ferromagnetic material of a field strength? Field strength of is given, and it is given as 220 ampere per meter. Field strength means what? So, applied magnetic field is given. Field strength. Field strength means H value is given, and its value is given as 220 ampere per meter. Then one more thing is given. It produces a magnetization 3300 ampere per meter. When we applied a magnetic field of 220 ampere per meter, it produces magnetization, means magnetization produced. We are using notation M. M is equal to 3300 ampere per meter, and we have to find out the value of mu r. We know that we have studied or we have learned two formula in this chapter. One is what is susceptibility of ferromagnetic materials. Susceptibility is the ratio of magnetization produced upon applied magnetic field or the field strength. And there is one more formula. It is related to relative permeability, and relative permeability of the magnetic material is equal to susceptibility plus 1. So in this we have to find out the value of relative permeability. But in order to find out relative permeability, we should know the value of susceptibility. But susceptibility value is not given, but it is indirectly given, because both these values, susceptibility is equal to m upon h, and they have provided us the value of magnetization produced, and they have also given us the value of h. So let's substitute the value of mu r. Formula will become m upon h plus 1. So mu r is equal to m. What is the value of m? M is nothing but 3300 ampere per meter. Divided by h value is given as 220 ampere per meter plus 1 plus 1. So the sign will get cancelled and we will obtain, after solving this, 3300 divided by 220 plus 1. This will give us value of 16. So mu r value comes out as 16. So relative permeability of a given ferromagnetic material is 16. Material is 16. Second example. Let's try to solve another example. Let's read it first. Our second example is the magnetic field intensity in a piece of ferric oxide is given as 10 raised to 6 ampere per meter. If the susceptibility of the material is 1.5 into 10 raised to minus 3, calculate the magnetization of the material and flux density. So, let's write first given. Magnetic field intensity. Magnetic field intensity means H value is given. Applied magnetic field is given. H is equal to, it is given as 10 raised to 6 ampere per meter. Then second, if the susceptibility of the material is, means susceptibility of the material is given. Susceptibility is denoted with this notation. Susceptibility is equal to, given as 1.5 into 10 raised to minus 3. It is dimensionless quantity. Then we have to calculate the two things, magnetization of the material and flux density. Means we have to find out what? We have to find out magnetization produced is how much, and second one is B. B means what? Flux density. We are calling it as magnetic induction. So we have to find out these two things by using these two things. So we will recall the formula those we have learned in this chapter. First is susceptibility is given as the ratio of magnetization produced upon applied magnetic field. Applied magnetic field means H, and in first part we have to calculate M. In first part we have to calculate M. So in order to calculate M, our formula will become M is equal to susceptibility into applied magnetic field. So substitute the values of susceptibility and applied magnetic field. Susceptibility value is given as 1.5 into 10 raised to minus 3 into value of H is given as 10 raised to 6. So value of M will become 1.5 into 10 raised to 6 plus 6 and 10 raised to minus 3. So it will come out as 10 raised to 3. And we know that the unit of magnetization is ampere per meter. So in first part we have calculated magnetization produced by using the value of susceptibility and applied magnetic field, and it found out as 1.5 into 10 raised to 3 ampere per meter. Now let's try to calculate the value of magnetic induction B. So, in order to calculate the magnetic induction B, we have formula as magnetic induction B is equal to mu 0, that is permeability of free space or the vacuum, into applied magnetic field plus magnetization produced. This is the formula for B, and this mu 0, that is permeability of free space or vacuum, it is a constant and its value is given as 4 pi into 10 raised to minus 7. Many times it is provided in the example and sometimes it is not given. So you have to remember or recite this value as it is a constant value. So permeability of the free space is given by 4 pi into 10 raised to minus 7. So let's substitute the values of given things. B is equal to magnetic induction is equal to 4 pi into 10 raised to minus 7 into value of H. H is given as 10 raised to 6 plus value of M. M we have calculated. M value is found out as 1.5 into 10 raised to 3. 1.5 into 10 raised to 3. Substitute the value of pi. Substitute the value of pi as 20t upon 7 or 4 into 10 raised to minus 7 into 10 raised to 6 plus 1.5 into 10 raised to 3, and you will obtain value of B as 1.257 is the value of B. It is magnetic induction and it is given in Weber per meter square, or B is equal to 1.257 Tesla. You can either use Weber per meter square or Tesla. So value of magnetic induction comes out as 1.257 Tesla. Let's start to solve one more example from this chapter. The example is given as the susceptibility of a paramagnetic material is given at 300 Kelvin and its value is 3.7 into 10 raised to minus 3. Susceptibility is given as 3.7 into 10 raised to minus 3 at temperature 300 Kelvin. Find its susceptibility value at 250 Kelvin and 600 Kelvin. We have to find out the susceptibility of the paramagnetic material at two different temperatures, one at 250 Kelvin and another at 600 Kelvin. In this chapter, we have seen various types of magnetic materials, that is diamagnetic, paramagnetic and ferromagnetic materials. In case of ferromagnetic materials, we know that the susceptibility is inversely proportional to temperature. As temperature increases, susceptibility decreases, and hence susceptibility is given as susceptibility is equal to C upon T. This is the formula of susceptibility, where C is Curie constant and T is absolute temperature. So, in this example given, what is given? Susceptibility of paramagnetic material is given. Susceptibility is given at what temperature? At 300 Kelvin is given, and its value is 3.7 into 10 raised to minus 3. So, from this formula, we will try to find the constant, Curie constant first, because In second part, we have to find out and find what we have to find. We have to find susceptibility value at 250 Kelvin and susceptibility value at 600 Kelvin. So, in order to find out these two values, one should know what is the value of Curie constant. In order to find out the value of Curie constant, we will substitute the value of T and the value of susceptibility in this formula. So, C is equal to, from the formula number 1, so C is equal to susceptibility into absolute temperature. Susceptibility value is given as 3.7 into 10 raised to minus 3 into T is given as 300. So, value of C comes out as 1.11. So, Curie constant comes out as 1.11. Now we have to find out the susceptibility at 250 temperature and susceptibility at 600 Kelvin temperature. So, first part, susceptibility at 250 Kelvin temperature can be found out by substituting the value of C by T. That is, C is nothing but 1.11 and T is nothing but at 250 we have to find out. And this value comes out as 4.44 into 10 raised to minus 3. As susceptibility is the ratio, it is unitless. Then in second part, we have to find out the susceptibility value at 600 Kelvin. Here also formula is same, Curie constant divided by absolute temperature. We have found out the value of Curie temperature, Curie constant. It is 1.11 divided by, now we have to find out the susceptibility value at 600 Kelvin. So we will substitute here 600 and this value comes out as 1.85 into 10 raised to minus 3. Here also it is dimensionless. So in this example, we have first found out the value of Curie constant and then find out the value of susceptibility at 250 and 600 degree Kelvin by substituting value of C and respective T. Thank you.